Welcome to the beginning of Chapter 2. So Chapter 2 is all about describing locations in a distribution. So let's take a look at our learning targets for the day. We're going to talk about describing location of an observation with a percentile, interpret the cumulative relative frequency graph, and describe the location of an observation with a z-score and interpret that z-score in context. So the first thing we're going to talk about is measuring position in terms of percentile. So one way to describe the location of a value in a distribution is to tell what percent of observations are less than it. So when I give a percentile, so the pth percentile of a distribution is the value with p% of the observations less than it. So for example, the sum plot below shows the number of wins for each of the 30 Major League Baseball teams in 2009. And it wants us to find the percentile of each of these. So find the percentile of the Colorado Rockies, who won 92 games. All right, so 92 games would be this observation right here, okay? So, and we're looking for the percent of values less than a percent of the distribution that is less than it. So let's count up. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24. We have 24 of the 30 values less than it. So its percentile is the 80th percentile. 80% of the data is less than it. How about New York Yankees, who won 103 games? Okay, so we've already done a lot of counting. So this was already 24 right there. So 25, 26, 27, 2, and 8. 29. So 29 of the 30 teams were less than it. So that's at the 97th percentile. And finally, Kansas City Royals and Cleveland Indians, who both won 65. So let's count up. 65 would be these right here. So here, 1, 2, 3. There's only 3 less than it, okay? Because with them grouped together, like they're equal, so being strictly less than, well, there's only 3 data points that are strictly less than it. All right, so that's how I find percentile. Again, we're literally looking just what percent of the data is less than it. So you can count it up, divide by how much data there was. All right, a cumulative relative frequency graph. What it does is it displays the cumulative relative frequency of each class in a frequency distribution. Or essentially, it kind of graphs the percentiles, okay? That would be another way to mark this. Sorry, my sideways writing isn't that impressive. But essentially, it marks the percentiles for each data point, okay? So again, I wouldn't be concerned with, I've never seen anyone have to draw one of these on the AP exam, but you do need to be able to interpret it, okay? So you need to interpret that when they say cumulative relative frequency, that is the same thing as percentile, okay? So, and this is the data that we were just looking at, okay? So let's take a look at what type of questions could they ask based on a relative frequency graph. Well, they're connected by the percentiles on the y-axis, so we can use them to find percentiles. So looking at the graph, we can ask, what is the 20th percentile? What value would be at the 20th percentile, okay? So again, I know we have the actual data, but I'm talking about learning how to read one of these relative frequency graphs. The 20th percentile is right here, so we would want to take it and see where does it intersect. Okay, so looking at that, I would say the 20th percentile is probably pretty close to something like 72 wins. Okay, the median. Well, the median, keep in mind, would be the 50th. percentile, okay? It's the exact halfway point of the data. So we could look in here. 50th percentile would be about right there. And I say that's probably like 82-ish games. Okay, 82 wins. Or I could go so far as to ask you, what is the interquartile range of the data looking at this? Now you may be wondering, how can I see that? How in the world am I supposed to do that? Well, IQR, remember, IQR is Q3 minus Q1, which, thinking in terms of percentiles, would be the 75th percentile minus the 25th percentile. So they ask you for the interquartile range, you can still find it because that is all based on quartiles. 75%, the 75th quartile, subtract 25th quartile. So let's clean this up a little bit. And 25th percentile is probably going to be somewhere about here-ish. Okay, so again, maybe 72, 73, and then 75th quartile. Like 89. Okay, and again, this is not exact. This is just roughly. So 89 minus, and we said what, maybe 72, 73. So the interquartile range is going to be about 17. All right, and I could label that 17 wins. It's going to be the interquartile range. All right, so that's percentiles and cumulative relative frequency graphs. Now let's move on to another way of measuring position, z-scores. So z-scores are going to be an incredibly important thing basically for the rest of the year, okay? So z-score tells us how many standard deviations from the mean an observation falls and what direction it falls in. So if x is an observation from the distribution that has known mean and standard deviation, the standardized value of x is that. So this is going to be extremely important, otherwise symbolically, excuse me, that's what it would look like symbolically. And this is often called the z-score, okay, standardized value. So let's take a look at this. Cassie is a member of the school's basketball team. The mean height of players on her team is 74 inches, as she is 75 inches tall. The standard deviation of the team is 2.5 inches. What is her z-score? All right, so let's take a look at this. Following this formula, so her z-score is her observation. So she is 75 inches tall minus the mean, which is 74, divided by standard deviation, which is 2.5. So 1 divided by 2.5, I'm going to use a calculator to do that because I don't know it at the top of my head, is 0.4. So, 0.4. Now, what does that mean? Okay, because the most important thing is understanding what are these values actually telling us. Okay, and what this is telling me is Cassie is 0.4 standard deviations above the mean. How do I know it's above? Well, because the z-score is positive. Okay. And so that's really all a z-score is doing, is counting how many standard deviations are you above or below the mean. Bryn is a member of a rival school's basketball team. The mean height of players on her team is 74.5, and she is 75.4 inches tall, and her height corresponds to a z-score of 0.6. What is the standard deviation of the team members' heights? All right, so This time, we're given what the z-score is. We're given her z-score is 0.6. We know that she is 75.4 inches tall. The mean is 74.5. Oh, and we're looking for standard deviation. Okay, so I'll use S for standard deviation for now. All right, so if we want to know what this is, well, first of all, the 75.4 minus 74.5. We can calculate that, and that's going to be 0.9. So 0.6 equals 0.9 divided by S. I can multiply that S over, and now I can divide by the 0.6. And it gives me that her team had a standard deviation of 1.5. So you can be asked to do various things with this formula. The important thing, obviously, is understanding how the formula works. Okay? So now, speaking of being compared to her own team, so compared to her teammates, which girl is taller? Okay? So speaking literally, Bryn is 75.4 and Cassie is 75. However, there's a little bit more to it, okay? So Cassie is 0.4 standard deviations above the mean. Bryn is 0.6. So I would base this on the standard deviation or the z-score, okay? You want to look for the greater z-score to see comparatively who is taller, okay? Because it standardizes those numbers. So based on the average and standard deviation, Bryn has a higher z-score, so she is taller compared to the rest of the team. Whenever you're making comparisons, you always want to make the comparisons based on z-score. So for example, if you're trying to compare if you did better on the ACT or SAT, you would want to use a z-score for that because the scoring and everything is different, okay? You can't just take the raw score and see how you did. Compare the z-scores. How did you place compared to the standard deviation and compared to the average? Now let's look at this. So looking back at the data that we started the lesson with, find and interpret the z-scores for the following teams. All right, so looking at these. So in order to calculate z-score, what do we need? Well, we need the mean and we need the standard deviation, okay? Now that's something that we're not given, but we could easily find it, okay? I taught you that back in section 1.3, that if you ever need mean, standard deviation, anything like that, you can go to the calculator and calculate it that way, okay? So we can go, now I've already done it, we can go input the data into a list. Okay, so all those numbers from the stem and leaf plot, I've already put into a list. And remember, to get that information, we can calculate a one variable stat. Okay, so for all the teams, the mean is 81. So we need the mean, and standard deviation is about 11.43. Okay, so mean equals 81, standard deviation is 11.43. And now we can do z-score calculations. Okay, so the z-score is going to be our observation minus the mean over the standard deviation. So 103 minus 81, that's going to be 22 over 11.43. That's going to give you about 1.92. Okay, so the New York Yankees score is 1.92 standard deviations above the mean. Okay, that's what interpreting a z-score looks like. How about the New York Mets? Well, they scored 70. So 70 minus 81 over 11.43. So 70 minus 81 gives us negative 11 divided by 11.43 is about negative 0.96. So the Mets score is 0.96 standard deviations below the mean. Okay, remember that's what a negative z-score means, that it is below the mean, less than the mean. All right, so that is it for today's notes. Thank you for watching, and make sure to ask if you have any questions for me.